So what is a binary file? What is binary file handling? So binary file handling is a process in which we create a file and store data in its original format, original format. It means that if we stored an integer value in a binary file, the value will be treated as an integer rather than text. Okay. So binary files are mainly used for used for storing records just as we store records in a database. So this is the basic idea regarding binary file system, right? So generally the program file which we keep, right, it is a text file, right? Program file is a text file, right? The recording which you will get it from the Skype, right, is a binary file. Okay. Any song which you are listening is a binary file. Text mode versus text versus binary mode. And think about storage of numbers. Okay. So if you write a number, right, storage of numbers. If you write a number like this, right, so the integer 127643 or 44, right, occupies 4 bytes in the memory, 4 bytes in the memory, right? It will occupy 4 bytes in the memory. But when this data, right, when written to a file, when written to a file, it will take how many bytes? It will take 1, 2, 3, 4, 5, 6 bytes, right? It will occupy, right? Everyone, I hope, understood this process. If you have any doubt, you can ask me. Understood, right? When it is in the memory, it is 4 bytes. But when you are writing it down into the file, right, it will occupy 6 bytes. So what kind of file I'm talking about? It will take 6 bytes. So I'm talking about text files, right? So when it is written in text file, written to a text file, it will occupy 6 bytes. Fine. And but when it is on the memory, computer's memory, it is occupying 4 bytes. Now you can imagine an array of 1000 bytes. Sorry, an array of 1000 cells, right? You have declared one integer array, say int A, and you have written here 1000 or say 10,000. So how many bytes it will occupy? It will occupy it will occupy 1000 into 4 multiply by 4 bytes on the memory, right? But when this data it will occupy more bytes. It will occupy more number of bytes, more number of bytes. Okay. How it is possible? You can think about a situation, simple situation. Let's take a very simple situation. So there is an array A. What is the data? What is the size of int type? No. What is the size of int variable? Normal int variable. How many bytes it will occupy on the memory? If you declare int of x, how many bytes it will occupy?
So 4 bytes.
4 bytes. That is what I have written. So in x, someone has stored 127644. So it will occupy how many bytes? 4 bytes. This x is occupying how many bytes? 4 bytes. But if you want to write the value of x in file, it will occupy 6 bytes. Right? What it will do? It will convert the whole data into text. If this data is converted into text, it will occupy 6 bytes. It will occupy how many bytes? 6 bytes. No, it will occupy 6 bytes. Right? So you can see that generally our data is numeric, right? So 4 bytes, it may be, say there might be values like this. Say I'm writing down here 12864443 1783765, right? There is a value 1443765, right? There is another value you can imagine 7643435. Then you have another value 852836761. Then there is another value 7400153. Okay, so 1 2 3 4 5 6. So I'm keeping this 6 value. So how many bytes it will occupy in the memory? This is memory. So if I want to store the array into the storage, then how many bytes it will occupy? And in the memory also, my question is that in the memory, how many bytes it will occupy? And in the storage, how many bytes it will occupy?
Sir, in the memory, 24 bytes it will take.
Okay.
And in the storage and in the text file, it will take 36.
It will take 36 bytes. Why 36? No, it will not take 6. It will take more. 1, 2, 3, 4, 5, 6, 7, 8. For every digit, it is taking 1 byte of data because it is converting every digit into a character. So this will take 1, 2, 3, 4, 5, 6, 7, 8. This is also 8. This is 3, 3, 6, 2, 8. In memory, it is taking 4 bytes only because what integer will be converted into binary, and that binary value will be stored in the RAM, right? But when you are storing in the storage, it will be stored in the text format. Got my point? It will be stored in the text format. Rajiv, understood? How many people are there? Tanveer is absent. No, Tanveer is also here. Tanveer, understood? So this is 8, this is 8, this is 8, this is 9, I think. So 3, 3, 6 to 8. Acha, this is also 8. This is 3, 3, 6 to 8. This is also 8. This is 3, 3, 6 to 8. This is also 8. So it will occupy how many bytes in the storage? 48 bytes. Right? So if you increase any one size increase, say it has more value, say 9. So it will occupy 49 bytes in the memory. If I will increase any digit. Got my point? So number of digits right, is number of bytes in the storage. That means if you have big array, then big integer array. So this is integer array. Fine. Imagine the situation like this. Say you have a float array. Float f. Imagine this situation. So you have a number like 112.476685. You have a number like 2.53. Okay. You have a number like 0.1476. Okay. 14763, 1, 2, 3, 4. You have a number like 17785.633. Okay. So you can imagine the situation here if you want to store these values into the file, right? So on the memory it is only 1, 2, 3, 4. So on memory, this will be occupying how many bytes? 4, 8, 12 and 16. It will occupy 16 bytes. But if you store it in the text file, store it in the text file, it will occupy how many bytes? 1, 2, the dot is 3, 4, 5, 6, 7, 8. 8, this will occupy 8, this will occupy 1, 2, 3, 4, this will occupy 4, then this will occupy 1, 2, 3, 4, 5, 6, 7, this will occupy 1, 2, 3, 4, 5, 6, 7, 8, 9, this will occupy 9. So total is 8, 4, 12, 12 plus 7, 19, 19 plus 9 is 28. So total is 28 bytes will be occupied. So generally now when you see Excel sheet, right, it is full of numbers, right? It is full of numbers. So if you use text file, what it will do? It will take huge amount of storage. In your SSD, it will occupy huge amount of storage, right? And as the day progresses, you need to buy a new SSD, right? If your data is increasing in this amount, okay? So for this reason, we will use binary file, because binary file, right? In binary file, we store the raw format, right? In binary files, if you use binary files, right? In binary files, we store raw format. Right? Raw format means the data, raw format means the data stored in the memory, that the data stored in the memory, in the same fashion, the data stored in the memory in the same fashion, it is stored in the file. It is stored in the file. Okay. So in binary file, we store raw format, the data stored in the memory, and in the same fashion, it is stored in the file to save memory on permanent storage device, permanent storage device, permanent storage device. Oh, sorry, permanent storage device, storage device. Okay. So I hope this concept is clear. So it will save memory, right? It will save. So it will occupy same number of bytes on disk as it occupy in memory. As a result, right, it will occupy same number of bytes on the disk as it occupy on the memory. So I hope it is clear, right? So how to record input and output in binary file, right? Say for text mode, what are the functions we have used, right? So we have used functions like fscanf, fscanf, right? fprintf, fprintf. These kind of functions we have used in the text mode. This is text mode method. This is another for binary file mode. We have methods like fread, and fwrite. Right? Instead of fprintf, what we do, we use a method called fwrite. This is for binary mode method. So let me write down a sample program for binary mode. It's a macro file star হবে, ঠিক আছে? আচ্ছা, তারপরে what I have to do, I have to write let's create one structure here. struct কি বানাবো? Let's create employee, struct employee. So employee having id, employee having id, employee having name, id, name, and salary. So id is integer, name is string. So character name 100, and salary is float. Okay, salary is float. So it's there. So let me write down the record. F open, and let's write down the name of the file here. The name of the file is employee. So I think I'll having one folder. So let's create the file over here in this same folder, right? So I'm writing down here emp.dat, and it will be, the file mode will be write binary. WB means B means binary, write binary. So I can write the binary data. Okay. Now what I will do, I'll declare the structure, struct employee, struct employee e. That's it, struct employee e. Now we can feed the information. Okay, so how we can feed the information? So we write here print f, enter employee id, enter employee id. Okay, enter employee id. Fine. Then we put semicolon. We write here scanf. Fine. Employee id is this. So we write down e.id. Then we write down printf, enter name, So we put a semicolon here. We'll write here scanf, enter name. Then we write down printf, enter salary. We put a space over here. Enter salary. then we write down scanf salary. So now what we do, we transfer this data into the binary file. To transfer the data, what command we have to write? We have to use fwrite. Okay, fwrite, and then we can write down ampersand of e, comma, I have to write down size of e, right? So how many bytes that e variable has occupied, depending upon that it will occupy, it will create a chunk of buffer and send that buffer into the file, comma 1, comma fp. fp is a file pointer, right? fp is a file pointer. So this file is created, and now we can close the file. So we write fclose fp. So we will create one record and store that record into the file. Okay, let's give a try whether file is creating or not. Okay, so we have executed the code. It's asking for employee ID. 0 came suddenly. I don't know from where. So employee ID is 101. Okay, name is Jam. Salary is 3400.15. Okay, so this is the salary. So let's check whether whether this file is created over here or not. So employee, the name of the file is emp.dat. emp.dat. You can see the file here, emp.dat, right? And when you double tap on it, now you will see that this is not opening. So let's click on open anyway. It's asking for some editor or something. So let's not try to open it, because it is a binary file, right? We can open it in the notepad and we can see. So file handling, you can see emp.dat file is there, and we can open it with the, now you can see the data, how the data is being stored. The data is stored in the form of operating system supported format. Okay, so my operating system is Windows. So this file work only on Windows operating system. It will not work on any other operating system. Okay, it will not work on Linux. It will not work on Mac, because Linux have a different format, different binary format, right? Mac having a different binary format, Windows having a different binary format, Android having a different binary format, right? So it will not work. But if you can see the character data is readable, but other data were not readable at all, okay, in the binary file. So let's try to read the file. Let's try to read the binary file. Okay, so let me write down another program for reading the file. Okay, this is for writing the file. So let's create another program for reading the file. We'll create the file here, binary mode 2.c. Okay, so what I'm doing here, I'm just copying this, because I just have to read a file. So what I will do, I will use the same structure also. Okay, but I will change the mode. So read binary. Okay, so here I don't have to input all this. Fine. And instead of f.write, what I have to do, I have to use f.read. Fread, not write. Fread. Fread. Okay, and yeah, fread. Okay, so fread function, when fread function is true, now it will return 1. It will return 1, and when it is false, now it will return 0. So if it is returning 1, then you can use a while loop here, while fread. Okay, and here you can write down printf. So first is id, so %d. So it will print the id. So you can write here employee ID is percentage D. Okay. So you can write here employee ID and the percentage D. And here you will write down E dot ID. Okay. Then you write down another printf statement name. Okay. E dot name, and you put a semicolon here. Then you write down printf, then name and salary. So salary percentage f slash n, and you write down comma e dot salary. Okay. So this is how you can write down the code, right? So if we add more records in the file, then we can read more records from this program. So that is why I have written the while loop. Okay. So let's execute this and let's see whether it is working or not. So now you can see the employee ID is 101, name is Jam, and salary is this. Achha. I did a mistake here. I did not. Achha, I have closed the file. I have not done the mistake. So I have closed the file. So now I can add more records, right, by using this program. Okay. So instead of write binary, what I can do, I can write down append binary. Okay. I can add more records to the binary file. Okay. So append binary will add more records to the existing file. So I am writing here employee ID 102, name is Kim, salary is 800.95. Okay. So this is these are the two records. Let me check why it is presenting 0. This is the reason why it is writing down 0. I don't want. So let me save this. Okay. So let's let's try to execute this program, whether it is printing the two records or not. So now you can see it is printing two records, now 101 and 102. Okay. So now what you can do here, you can add more records. So you write it down 103 and the name is Peter. Salary is 1200.45. Okay. So now what you will do, you execute this code and now you can see it's displaying all the three records. Okay. And you can open the file and you can see how the records were stored, right, as a binary mode. So open with notepad and you can see the records. So this record is not readable at all. No, this is not readable at all, but it is another way ki it is safe also. It is much more safer than the text file mode, right? So basically no one will disturb this file also. I hope this much is clear to everyone. Fread function, fwrite function is clear, right? So let me paste the code here. So this is for reading the file. This code is for writing data in the file. This code is for. I hope idea is clear. Rajdeep is not answering. Tanveer, idea is clear? How to create a binary file and how to read the data from the binary file.
Yes.
Okay.
Yes, sir.
Chalo then. Now we try to focus on modifying record. So modifying record, right? So when we open, 1 minute. When we open a file, fopen returns a pointer, a pointer to a structure, This structure this structure contains a pointer, which points to the first record, which points to the first record in the file. That record fread always reads that record where the pointer is currently placed, where the pointer is currently placed, okay. Similarly, fwrite always writes the record where the pointer is currently placed, I hope you have understood the purpose of fread and fwrite now properly, what it does and how it does. Okay. So on using the function fread or fwrite, the pointer always fread or fwrite on using the function fread or fwrite, the pointer moves to the beginning of the next record. On closing a file, the pointer is deactivated. Okay. Acha. So this is the basic idea about the fread and fwrite function, right? Acha. There is a function called the rewind function. Rewind function. What do you mean by rewind? Yes, Tanvir, what do you mean by rewind? Any idea? Rewind means ke it is there in the playlist, song playlist, na rewind button is there, right? If you want to listen the playlist again, then you have to click on the rewind button, right? So similarly, rewind function is there, right? So rewind function places the pointer, to the beginning of the file, okay, irrespective of where the fseek function lets us move the pointer from one record to another. to another. Okay. These functions have been used in the code to modify an existing record, an existing record in a file. Okay. So I hope this idea is clear ki how to modify a record. Okay. So let's try to modify one record. So to modify the record in the file, which mode we will require? Which mode is required to modify a record? We need to read the file and then we need the permission to write the file. Okay. So we need a mode called read binary plus, right? Read binary plus mode is required to modify the record in the, I hope it is clear. So let's modify the record. Binary mode 3.c. We'll write here hash include, then we will write here. So here we'll write, we can write it down here, equal to fopen, and we'll write here the name of our file is emp.comma say read binary, so we'll write down here read binary plus, we can read and write. So now what we can do, we need the structure also now, this structure is required. Now what we can do, we can ask the user enter the employee ID to modify. I will ask this. Okay, this will be written inside print f statement. So we'll declare a variable here, integer eid, and we'll take the input here. So we'll write here scanf %d ampersand of eid. Okay. So now what we do, we try to read. Okay. So in the condition part, we'll write eid, no, not eid. We'll write fread. To read the function, what we do, we need to write down fread function. Fread. We have not declared the structure here. So let's declare the structure here also. Struct employee say e. This is the structure variable, right? So what we have to do here, in the fread function, we need to write that. Okay. So fread. So what is the construct for fread? So I have used fread twice. That is why it is producing error. So it will read the data in E. Now what I have to do? I have to check if E dot id is double equal to eid. Okay. Then I have to modify this record. Okay. So then what I will do, I'll declare another structure, say E1. Now what I will do, I will take the input. These inputs are there now. Employee ID, a new employee ID, name, salary will be stored, and I need to write down the data also. Control C and Control V. Okay, Shift Alt F. So I have written this. Let me close this one. So what I have done, I have, if the employee ID is matched, I will take the input, right? And I need to go back, right? Because when the data is being read, right, in the file, the cursor has moved to the next record. The cursor has moved in front of the next record. So what I have to do, I have to go back, right? To go back, I have to use a function called fseek. Fseek, okay? Fseek function is required here. Fseek, fine. Fseek function is required here. Fseek, okay? So file pointer I have to put, right? And here, how many bytes I will move back. So I will write here size of E. The seek set will be seek set. Now this I can put, this I can put, this I can put, this I can put. Now this I can put seek 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 underscore seek underscore current, right? I got it. Seek underscore current. Okay. So from the current position, it will move number of bytes back, right? I want to move my bytes back. So what I will do, it will return size of E. So what I will do here, I will put a minus sign here, right? What I am doing here, I am putting the minus sign here because I need to move back. Okay. So that is the record size. Okay. So it will return me minus, negative, it will go back, right? So that is the record size, fine. Then, no, I can do one thing. I can create a variable here. I can create a variable here, comma. This is number of bytes. So record size. Record size is the number of variable. So what I will do here, I will use the record size. I will use the record size, fine. I will use, then it will be much more easier, okay. So here I will create a record, no, not here. Record size will be different, no, every time it will be different. So what I will do here, I will create a record size. Record size is equal to control V, size of V, fine. And this input will be in E1, not in E. This will be in E1, not in E. Okay. So size of E, I will move size of E. Okay. And when I am writing it, this will be record size. Record size. So record size will be negative. Okay. And here I will write it down E1. So from the current position, it will move to that position of byte, and there I will write down the new record. Okay. There I will write down the new record. I will break the loop. Okay. I will break the loop, fine. And after this, what I will do, I will close the file, right? I will write down fclose and I will write down fp semicolon, okay, to close the file. And here I can write down printf. Here now I can create, I can say that if this has executed, I can say that printf record is modified. record is modified successfully. Okay, in this way we can modify the record /n and put a semicolon here and break the loop. Okay. So this is how you can modify the record in a binary file. So let's modify this, right? So let's execute this, and I want to modify 102 record, 102. So it's asking for employee ID, right? That means 102 has matched. So I'm keeping it as 105. Okay, name as Ajay. Salary is 1300.78. Okay, so it's saying that record is modified successfully. So let's see whether the record is being modified successfully or not. So we'll execute this code, right, which we have already written. So let me execute this code and check. It's showing error. Temporary error, expected declaration specifier or ... before ampersand token. Here now I have not used a rewind function. I need to use the rewind function. I think the file is being disturbed a little bit. Rewind. And here I have to pass the file pointer fp. Okay, I did a small mistake here. Record size. No, this is fine. Here I did a mistake. I've written here ampersand of E. This will be E1, not E. This will be E1, size of E1, 1 and F. This is the file now which we have created. And let me write down because the file is disturbed actually because of my code. So let me save this. I'm using write binary to delete all the data and creating the data and new data. So employee ID 101, employee name, say John, salary is, earlier it was reading properly, now it is not reading. It's saying unknown type file pointer fp before ampersand, but I have used here E. But let me create another file, create another time. Employee ID is 101, name is, file is here only, emp.dat. Now I want to read the data. Okay, now it is working, fine. So now what I will do here, there was a mistake now that is done over here. So here I have only one ID, right? Let me cancel this. Let me put more records. From here. So let me put here append binary. Let's execute this. So employee ID 102, salary is this. Let me put more records. Then 103, salary is this. Let me put one more record. So 10, salary is 1100.35. So let's execute this program once again. So it's showing all the records. Okay. So now let's click on the binary modify one, right? And I want to modify the Silpa's record, right? Let's execute this one. So let me write down here 10, Shilpa is 102. Employee ID 102. I'm keeping it 102. And I'm writing down Shilpa, 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 right? And the salary is, right, I'm writing here 1900. Okay. So it's showing that the record is modified successfully. Okay. Now we go to this file and let's try to execute this one. So now you can see the Shilpa's record is modified properly. Okay. So if you do a little bit of mistake in the modification, right, it will hamper the binary file, right? So you have to be careful what variable you are using, right? So before executing the binary file modification program, na, always, right, always revise it, okay? Otherwise it will hamper your file, right? It will disturb the file and then you cannot read the data from the file, okay? So data of the file will be read, right? Depending upon how you are storing the data, it's very much important, okay? So I hope everyone has understood how I have modified the record. So these things are there, okay? So fseek function is very much important. So this is a rewind function which I have used here, rewind, to move the record pointer in at the first record, okay? Rewind function. Fseek, in the fseek now we pass the file pointer, right? We pass the position. This is the position, right? This is the position, right? This is the position, okay? And from this position, where you want to, where you want to go from which position, right? So if you write here seek end, so here if you put 0, if you put here 0 at the position, right? So this will take the record, right? This will take the record to the first position. This command, this is very much important. It always comes in objective, okay? So this command or this function call, the record pointer, move the record pointer on the first record, on the, so there were, you have seen that key I have used, there were constants, like there were 3 constants, basically 3 or 4 constants are there. So one of the constant is seek end, right? Seek end is a constant. Seek end is a constant, okay? There is a constant called seek cur, which I have used in the program, okay? There are other constant like seek underscore set, seek underscore set dot seek underscore end, seek underscore end, okay? So seek cur means move the file pointer with the reference to the current position, right? Seek set, seek set, seek set, seek set, seek set means move the pointer, move the pointer with reference to the beginning of the file, to the beginning of the file, to the beginning of the file, okay? I hope this idea is clear about fseek. Fine?
Yes, sir.
Okay. So you want to know ki where is your file pointer, right? Where is your file pointer currently? You are reading the record and you want to know ki where is your file pointer. So there is a function called tel, ftel. There is a function called ftel, okay? And that is here now you have to pass the file pointer. This is the file pointer, and it will return a value. That value is called long int. That value is called long int. So this variable is of type long int, okay? So it will return you the position, the current position where your file pointer is. Say for example, you were reading this now, you were here. So it will return you that position. Fine. So ftel function returns, ftel functions returns where is your file pointer, right? So ftel function ftell function returns the pointer, the file pointer, not the pointer, file pointer. Don't confuse the pointer word with the pointer concept. Pointer means you were moving, the cursor is there, na cursor, right? Let me talk about cursor here. Let me use a word cursor. Returns the file cursor, right? Instead of pointer, what I am using? Cursor. In the question paper, you may find pointer, because in many book na pointer word is written and it is confusing because you are studying this chapter after the pointer chapter. Okay, so this might be confusing. Array pointer, no, this is not a pointer, this is a cursor, right? With the help of the cursor we write now, we move the cursor. So it returns the file pointer or cursor. Okay, it returns the pointer or cursor, right? Cursor position byte number. What it returns? Byte number. Which byte it is, right? It may be 100, it may be 200, it may be 300, whatever, right? Where the position is a long int, right? This position is basically long int variable, right? This position is basically a long int variable. I hope you have understood what the ftell function does. Okay. So with the help of ftell, you can understand ki where your pointer is positioned in the binary file. Okay. Acha, this binary file is used in robotics. You have done robotics, any robotics campaign?
No, sir, not here.
Not yet. So it is mainly used in robotics, right? If you do Arduino project, then this file is used. This kind of a binary file is used. We discuss. So this part is not there in our syllabus. Otherwise, I have discussed a low level file input output also. Low level file IO. Okay. So this part is not there in your college syllabus. Okay. So I hope these questions will come. What is secant? What is seeker? What is seekset.secant? Right. So you need to understand this. This is important. Okay. From here now you may get 2 to 3 marks questions in your question paper. Okay. And from this concept also, how to move the file points. So binary file is finished. You try. This was the last topic. Now, in the homework, you try to delete the data from the binary file. Just only one homework. Input a record and delete the data. Just wait, I'll give you the program files and nodes. So binary file mode 2, share with Skype. Here, done. Binary file mode 1.c, share with Skype. Done. Then binary file mode C, share with Skype. So these 3 programs I have written, I have shared with you. Okay. And I'm sharing this EMP file also if you want to play with the thing. But I don't think so it will work in your computer. If you are using Windows computer, then it may work, right? If it will not work, then change the mode of the first file and execute the program. It will create the file in your computer also. Okay. Acha, let's go back to the notes. So we have done file handling. Oh, not here. It's PDF. Binary files in C. Share with Skype.